Everyone, welcome back to my channel Learning Math with Shelly. In this video I'm going to discuss about some more questions which are a little harder as compared to the previous one, which I discussed based on the equations of lines in 3D for the vector equation and the parametric equation. So as we already know that how to write the equation of a line in 3 dimensions or in 2 dimensions as a vector form or parametric form, which is given as r vector is equal to vector a plus lambda times vector b, where lambda is a scalar, a, b and r, these are the vector quantities. Now the first is they are asking in question 6 that find, this is the equation of a line given which is exactly same as this one, and they are saying find the direction vector of the line, which is very simple. That is, they are telling us about, they are asking us about the direction of this line, in which direction it is going to. So this b always tells us about the direction. So here the direction vector is -2, 0 and 3, and this is the vector equation. And if you look at the b part of this question, it is given as x equals 5 minus t. So I believe you understand that this is the parametric equation. So we have 5 minus t, y is equal to 1 plus t, and z is equal to 2 take away 3t. Here if you look at the second part, which is like minus t, then we have plus t, and then we have negative 3t. So if I take a t common from here, so I will be getting it like -1, 1 and again -1. So this is the direction vector here. Okay. Then the second important point, and that will be discussed in this question number 7. So what is that point? Find the coordinates of the point where the line with the parametric equation x equal to 1 minus lambda, y equals 3 plus lambda, and z equals 3 minus lambda, that will be meeting yz plane. So for example, I have a line, and this line is given in a like 3 dimensions, because here we have x, y and z, all the 3 components, and they are asking, this is a line in space in 3D. They are saying find the coordinates of a point where this line meets the yz plane at x equal to 0. So in that case, if I have to find out the coordinates of point, so first of all, let's say we have no idea about this question, so I will be just writing r, and that is equals to a plus lambda b. And if I substitute the values whichever are given to us, so I can write down r is equal to 1, 3 and 3. How did I get these numbers? From these ones, the first values which are written in x, y and z expressions in these equations without lambda, those 3 values will form a point on the line, and then plus lambda, and then I have -1 from the x, and here it is plus lambda, so lambda is outside, inside will be 1, and then -2 here. So basically this is my line, these are the direction vectors of the line, and this is one of the point. Now what they are saying, that the line is meeting the yz plane. So basically this line is meeting the yz plane, so that means if it is a yz plane, that means their x will be 0. Okay, if it is a yz plane, there is no x component, so x will be 0. So the point where they will meet, the x value will be 0. Now we know if we have a simple line y is equal to mx plus c, and this is coinciding with another line, so what do? We take the point, let's say we say this line is intersecting with another line, and there is a point with x equal to, let's say 2 or 3 or whatever. So what do? We take this point and we substitute in this equation. Same thing exactly we are gonna do here. So r is my general point. So for certain value, because x is 0 and they are meeting there, so that means when I write r point as x, y, z, here instead of x I will be writing 0. Y and z I have to find out, because this y and z can be anything that we have to find out, but x is 0, so this will be equal to 1, 3, 3. That means I am equating plus lambda -1, 1 and -2. Now from here I can take the first component because these are the vectors on both sides. So I can equate their x components, y components and z components. So when I equate the x components, I get 0 on the left side, and that is 1 minus lambda, which is going to give me lambda is equal to 1. So the very purpose of giving this equation here, this part, is to find the lambda, and that will help me to find out the y and z value. Then y is equal to 3 plus lambda, and as we got lambda as 1, so y is equal to 3 plus 1, so y is equal to 4. And then we have the next point, z is equal to 3 minus 2 lambda, and substituting lambda as 1, so 2 times 1, so z is equal to 1. So what will be the point? X is 0 in yz plane, y is 4 and z is 1. So this is the point where the coordinates, which is like yz plane intersects with this parametric equation which is given to us. Same way you can do the question like xz plane, that means y will be 0, where the line will meet xy plane, that means z will be 0. Sometimes in the questions this part of information will be given, and if it is not given, you have to understand it by yourself, that if it is an xz plane, that means y will be 0 over there. Okay, now let's go to the next question here. Next question is here, the parametric equation of the line are x equals to x naught plus lambda L, y is equal to y naught plus lambda m, and z is equal to z naught plus lambda n. Find the coordinates of the point of intersection corresponding to lambda 0. So that is pretty easy. What you can do over here, you can just take x as x naught plus lambda L, y is equal to y naught plus lambda m, and z is equal to z naught plus lambda n. We just need to substitute lambda as 0. So we will get x equal to x naught, y equal to y naught, and z equal to z naught. And same way, if you have to find out the direction vectors, so just see that scalar is lambda here, so it is multiplied with L. So the direction vector for the x component is L, for y component it is m, and for z component this z it is n. So these are the direction vectors, and the coordinates of point, that is x naught, y naught, z naught. I am covering all these questions from the Hayes Mathematics book. That is really a good book if you want to practice the vectors in 3D. They give some complex questions, but starting from the basic one. So I am trying to cover all the questions, or I am giving you an idea of the different type of questions. Okay, thank you.